Today we are on topic 6. So topic 5 was on web client security. So we discussed about browser security and security architecture in a browser, and how to enforce same origin policy through browser implementation and architecture. But a lot of the information that is sensitive, for example credit card information, banking information, or even your emails, those are actually on the server side, right? So many of the attacks that we normally see are on the server side. So we have to look at a web server security, and we have 6 modules, and as we'll see very soon. So the first module is looking at the major web server threats, and one of the major threat is command and SQL injection attack, which we'll do in the module 6.1, and then module 6.2 will be on cross-site request forgery, and module 6.3 would be cross-site scripting. 6.4 will be defenses and protections against cross-site scripting, and then we'll talk a little bit about how to find vulnerabilities. So there are tools that are used for finding vulnerabilities in the code on the server side, as well as penetration testing for finding various vulnerabilities. And then 6.6 will be a little bit on secure development. So how to create a development environment in which security is taken seriously and as a prime concern. So module 6.1 is a major web server threat, which is command and SQL injection. So 3 major web server threats we are worried about here. I mean, there are many more, but in this course we will talk about the 3 major ones. So we'll see that if you look at the OWASP, which is an open non-profit organization which collects web threat informations and actually disseminate them and rank them based on real data. So they publish their top 10 vulnerability list every year. So this is a little bit from 2013, so it's a little bit old, but it's sort of similar even today. So one of the major one, which is first one here, is the injection attack. So untrusted data is sent to an interpreter as part of the command and query, right? So it could be a a Perl interpreter, or it could be a SQL query execution environment where untrusted data is sent without checking that it is not going to do any harm, and then once that data is interpreted on the server side, you will find that it may delete your database tables, it can exfiltrate information from your database, or it can execute a command on the server side and delete files from the file system and so on. So unless you are properly designing your server side with isolation and confinement and proper privilege setup, you might be in trouble through this injection attacks. Then there is another is authentication and session management. So attacks on passwords, keys, and session tokens, and so these are ways to actually log you in somebody else's name, or stealing your password, or stealing your session tokens and hijack your session, things like that. Cross-site scripting is another one, big one, in which an application will take some untrusted data without checking its sanity, and it's sent to the web browser, and the web browser tries to interpret it using rendering, and then in the process it might do something that you don't want it to do, or it might steal your information and things like that. Now, of course, there are many implementation problems on the server side that could, as I said, that you have to have your proper confinement. You should use the principle of least privilege. You should not have buffer overflow and things like that on the server side. And if you have those, if you have a misconfiguration and so on, so then you will be obviously attacked. And then number 8 in that list was cross-site request forgery, or CSRF. So we'll talk about that in detail. So basically in CSRF, what happens is that when your browser is logged onto a good website, an important website, then somehow the attacker make a request to that website that you didn't mean to do, but because of the attack your browser send that request, and some data gets changed at the server side, or some account is used to pay somebody else, and things like that. So these are some of the major server side problems. So as I said, that we'll talk about 3 distinct vulnerabilities in this class. So first one, big one, is an SQL injection. In SQL injection, so the browser sends some input to the server to make a database query. Let's say the browser actually is displaying a form, and you are supposed to type in the information in the form fields, and then the form fields are not properly checked on the server side or the client side, and therefore when that information in the form is used to construct an SQL query, your SQL query may become something that you did not mean to query about, and therefore some data may get exposed, some information may get changed, the database may be harmed by deleting the table, and so on. So in order to prevent SQL injection, either there should be some check when the form fields are filled. The form fields could do some checking that it conforms to certain restrictions, or at the server side, before the SQL query is constructed from those information, the server side code must check the sanity of the input that is coming from the browser. So that is SQL injection, and this is very common. So for example, our OARS had SQL injection for a long time, and actually last April 2016 April, we actually found that even the password field was having an SQL injection, and therefore I mean, it has been fixed now, but what happens is that if you design your web server and the client code in a way that is not cognizant of these possibilities, then you could have this very easily. And even we found that Vishwasharaya scholarship scheme had SQL query injection, SQL injection in its login page, which is actually a website designed at the Media Lab in Singapore. So this is not uncommon at all. CSRF, or cross-site request forgery, is the second one that we'll talk about. And in this, what happens is that it basically fools a victim to use a live session with another server, and basically the attacker will fool the victim browser to send a request on its behalf on the authenticated session, and therefore the server side will think that this is a genuine request, and it will change the database or change the bank account information, do transactions on the bank account on behalf of the attacker through somebody who is not even aware that this is happening. So CSRF is a major concern, and lot of work has been done on making things CSRF proof. For example, as you must be pretty familiar with the CAPTCHA. So CAPTCHA is one way of actually preventing CSRF, because for your login page, for example, you have a CAPTCHA, so and it changes every few seconds. So therefore, if somebody has fools your browser to log in on its behalf by somehow making your browser send the login information on its behalf, the CAPTCHA will not match, or the CAPTCHA will be a problem. So XSS is a cross-site scripting. So basically somehow the bad website or bad web server sends a victim browser a script, and that script is basically can steal information from an honest server, and we'll see how that happens. So to reiterate, the SQL injection changes the meaning of database command by manipulating the command itself. CSRF leverages an existing session by a legitimate user to a legitimate website and make it work on the attacker's behalf. So the victim is unaware that it is actually communicating with the web server on which it is actually having a legitimate session to do the bidding of the attacker. And XSS, as I said, that it injects malicious script into a trusted context. So it might actually even inject a malicious script inside the inside the server, and it might be downloaded innocuously by the victim, and so on. So let's look at the command injection. So the attacker basically wants you to execute something on the server side, and when it finds that you have a web page in which you have a form field that is not checked for sanity, then it can actually put certain commands in that form field, and if the server side blindly trusts what it gets from the form field from the HTTP post message, then it will actually execute it on its behalf. So let's take an example. Let's say you have a PHP based calculator on a particular website you are hosting. So users are allowed to go to the website and on the browser type in an expression, and the calculator is supposed to evaluate the expression. So the way the code will look like, so here is a get expression and then eval the expression and output the result. So the way one could do is that it could actually do an URL encoding. So in the fragment part of the URL, it can put a query, and instead of just having an arithmetic expression, it could also have some command that a PHP interpreter would be able to execute. So for example, in this case, it's saying make the system call to remove star dot star. So it will basically delete the entire directory. Of course, on the other side, depending on the security architecture on the server side, this may or may not be allowed. So assuming that the server side is not designed correctly, this could actually do the harm the attacker intended. And many times one thing that you should be aware of, that many of these special characters that are used in a query like this, there may need to be an URL encoding, because you can only send ASCII characters through HTTP. So therefore, if you are having some characters that are not a part of that, then it will actually do an ASCII encoding of that. So similarly, another example. So here you have a PHP based emailing application. So this you see in many sites where they don't ask you to email through your email system. They have a form field where the email address is to be given, or like you booked a ticket and you want to send the itinerary to another person. So you are asked to put the email of another person, and then it will automatically send the itinerary to the other person. So the way this might be written is that from the post request you get the email field, you get the subject field, and then you execute a system command that mail to this email address with the corresponding subject line, and then the content of the email is already in a file that has been either auto generated, or in case of just a propaganda email, it could be just a fixed file with fixed information. So now what the attacker can do, if these email fields and the subject fields are not properly sanity checked, then what the user can do is that it can say that I want this hacker email, and in the subject line it by itself puts instead of just giving the subject, it also gives that redirect the user password and file and the ls command. So the hacker will actually get by email the password file and the file listing. And then worse yet is that instead of since you are allowed to put anything here, as long as you put this email and subject, and then after that you are supposed to make a command, or in the subject itself you can say echo eval :0 :0 root. So what it means is that you are creating a user with no password and giving it a root privilege, and then you are basically using this entry and the shell that will be open for this user, and then put this whole thing to the /etc/password. So this basically will create an entry into your password file, and that will allow you to have an access to this server without a password and with root privilege. So that's command injection. So in SQL injection is a little more structured, because SQL is a language for querying databases, and most of you know SQL language. So it's a language in which you basically consider tables in a database, and then you say which table and which column of the table or which columns of the table you want to consider, and then you give maybe if you with a where clause you basically give a condition. So what this select person ID from person where username equals recipient means is that there is a table called person, in which there are entries for rows in that table are for different person IDs, and then person ID in those rows is one of the columns, and then what you are asking the database to give you is the ID from the person table where the username matches with the recipient. And where is this recipient coming from? Recipient is coming from the form. So you, let's say there is a form in which you are typing in a name, and that's recipient, and that comes to the HTTP post request, and that has been picked up in this variable recipient. And then you are asking for the result set by telling the DB to execute the query, and the query variable name is SQL. So what you have to understand here is that we are creating an SQL query on the fly. The SQL query is dependent on what you are getting as HTML messages, HTTP messages, and what the content of that is. Now if this recipient is a string that changes the meaning of the query, then what happens? So let's see how we can do that. So actually the way to do that is, let's say you want to know all person IDs. So you want to basically get the entire database's list of names, right? So instead of saying where username equals recipient, you can also add or you put an or with this condition and say 1 equals 1. So if username even if the username does not match the recipient, because you have an or and 1 equals 1 is always true, so this will return you the entire list of person IDs from the person table. So what that means is that unless you make sure that the recipient field that has been sent to you through an HTML form and through HTTP message, if you don't check the sanity or correct danger level of the value that you are getting, then you could be actually compromising your database. So the basic picture of SQL injection is that you have normally the attacker is at the browser, right? So in this case the attacker is not in any server, but it's on the browser, and there is a victim server which is connected to a SQL database, and this database actually is containing important information in tables. So the attacker, what it does is that it knows that this victim server is actually has a front end, web front end, through which it accepts various form fields, and then based on those form fields it constructs SQL query and sends it to the victim, sends it to the SQL database. So by knowing that, and by guessing that the victim server is not properly programmed, so that it checks the sanity of the inputs that comes through the browser, it basically fills the form field with very specific kinds of patterns. So for example, in the previous case what we said is that you can choose any recipient name and then put an OR and say 1 equals 1, and if the sanity is not checked, then that will be put into the query, and then this unintended query will go into the database, and then the browser will receive the result set, because that is how it is designed. So about a decade ago, a company called Card Systems actually went bankrupt because of SQL query injection. So it was actually a credit card processing company, payment processing company, and with the SQL injection attack, 263,000 credit card information were stolen from the database. So they were actually keeping this credit card of customers information in unencrypted form. That is one mistake. Second mistake was that they actually have SQL injection vulnerability, and therefore somebody who discovered it basically exfiltrated all this credit card information. So obviously the number of credit cards that were exposed was pretty large. So nowadays this has become much more common than how it is how it was then, and we know that credit cards got stolen from the PS3 gaming network. We know that credit card informations were stolen from Target in much larger numbers, but they haven't gone bankrupt because the things are quite different now. Now just to tell you that how common the SQL injection vulnerabilities are. So WordPress, through which many of you might be actually maintaining your website, they have had a whole lot of vulnerabilities related to SQL injection, and if you go to CVE database you will see many of them. So if you go to CVE database you will see SQL injection is rather common for many systems. So we actually showed you the trends of various cyber security vulnerabilities in the web sphere, in the web domain. And in the first module of topic 5, and if you remember, SQL injection was pretty large. Now it has reduced a little bit because of the awareness of the implementers. So just to give you some more examples, so suppose say this is an ASP example, where again an SQL query is being constructed while while your login request is being looked up at the server. So it says that select all everything, all fields from the table called users, where the user is matches the whatever you get from the form field, and password matches whatever you get from the form field. And if the OK is it's not OK, then you will fail. If it is OK, then you will be have a login success. Now question is, can you exploit this? This is how you can exploit this. So here is your, on the left you have your web browser, and on the next to it is the web server, and then you have the database. So web browser, at the web browser you enter username and password, and if you are an attacker you will malform the username and password. So here in this example right now we are not looking at an attacker, we are looking at a regular user, and the regular user puts username as me and the password as 1234. The web server gets it, constructs the SQL query for that, and then sends it to the DB, and the DB would send back the result set, and the web server then can send the result set or part of the result set to the browser depending on what the application is. Now suppose I am an attacker and I say I want to insert something like this. I said that or 1 equals 1 into the user. So instead of having just an username, you are putting this or 1 equals 1. In that case, even if the user doesn't match, the password doesn't match, the query will succeed. So then the dash dash basically causes the rest of the line to be ignored in SQL syntax. And then the bad news is that many existing systems have this kind of vulnerability in login. As I said, that our OARS had this vulnerability until last April. Now the user could do more harm than just to read your table information like this. It can actually first do something and then say drop table users. So users table will be completely removed from the database. So that can be really bad. It can also go and execute a query that changes an entry. So it can change the password if the password is being stored there, and so on. And then user can also do command shell and then say that create this new user with this username and password. So mostly many people don't do a privilege separation or least privilege principle based design of their server. So they usually run the SQL server as a system administrator, and then in that case the attacker gets much more latitude than normally it would get if it was running at a lower privilege. So this is a cartoon, but this kind of brings home the point that I mean, obviously it's an exaggeration because it's a cartoon. So here is the mother getting a call from the school. The school is saying, this is your son's school, we are having some computer trouble. So the mother says, oh dear, did he break something? So he's talking about her son, and the other side says, in a way. So then they said, did you really name your son Robert quote parenthesis semicolon drop table students semicolon dash dash? So the mother says, oh yes, little Bobby Tables we call him. So the school is saying, well, we have lost this year's student records, I hope you're happy. So the mother says, I hope you have learned to sanitize your database inputs. So that's the story, but so nobody really names their son like that, but somebody could, a parent could actually go into the school's system if they are allowing them to, and many times the US schools do that the parents can go and look up their words performance and so on. So if the parent is an attacker, then they can actually write, in case of son's name, they can write this kind of thing, and if the school's server is not sanitizing its inputs, then this can happen. So to prevent SQL injection, we normally suggest, it is normally even OWASP pages actually have all kinds of information and all kinds of preventive measure advices. So never build the SQL commands yourself. So use parameterized or prepared SQL statement, or use this ORM framework, which basically maps objects to to relational objects to various queries and so on. So example of parameterized or prepared SQL. So usually they use skipping of the arguments, and then so for example, suppose you are doing an SQL query, so you basically create this placeholders. So in this case, user and password are placeholders, and then they are actually added with the parameters the real request that user and requested password, and then you execute. And this add methods actually are going to check the sanity of the inputs before actually they are put in, and escape characters are put in.